streaming. There's not any obvious way to be sure. I guess I can hop over to my other computer and have a look at it and see what's going on over here on my secret computer. I'll have to mute it this time though, because otherwise there are all of these kind of horrible feedback problems. So let's do that. Hop on in, go to my channel here, and whoa, there I am. I can see me in the past looking over at my other computer. I can see me in the present on this computer, and that's pretty cool. I'm not sure if I hear audio, so there's got to be a better way to do this, to know that things are working, than to have another computer that I test everything on live. That doesn't seem like the way that you're supposed to be doing this. That's my strong opinion. And yet it's the way I'm doing it right now. So there we go. Let's see. I'm just gonna sure, I'm not hearing audio coming out of this computer. I definitely am not. It's odd. It's a little bit of an odd situation. Oh, is it muted? Is it muted? Oh, yes. Okay, it turns out I was talking and it was working and audio was being played all along. Yeah, perfect. I just had it muted, and so everything's good. Okay, I'm going to close that window now. I do have, if there are viewers and you are logged in, you can chat in the chat window. I have my second computer open with the chat open, so you could type things. I would read them, and then we could have this kind of streaming interaction, viewer, audience thing going on that you're supposed to have. That's kind of one of the deals of this medium, I think. All right, well, there I am, tiny in the corner. That's great. I'm going to Alt Tab over to my Scratch window, which I have full screened this time, so that's pretty cool. Last time I did not have it full screened, and so you could see my bookmarks. But this is a little better. It's a little more screen real estate, and a little less seeing the random stuff that's on my screen. So that's good. We learned something. I think I should be a little bit less sparkly this time. Last time I noticed there were a lot of sparkles in my green screen. My green screen lighting wasn't set up right. My camera had all these kind of autofocus things that it was doing. I had accidentally set a bunch of its settings to be automatically adjusted on the fly. So I set it up and it was working and everything looked good. And then the lighting in the room changed or whatever, and it readjusted itself and everything was ruined. So I think it's all on manual settings now. I don't think it should be automatically adjusting to make sparkly background anymore. So I think it should be all invisible. So that's pretty cool. So I'm going to hop back over to here. I'm going to go to Test Stream Platformer. I'm going to open up this Scratch project. I'm going to see inside. Before we get started doing anything else, I'm going to Test Stream Platformer. I'm going to give it a new name. I'm going to call it number 1, because this is the code from the first stream. I'm going to click File. I'm going to say Save as a Copy. And I'm going to make this one number 2. So that way we have a record of the code that we wrote the first time around, and then we're going to have the changes. So we will always have the most up-to-date code available, but we will try to save a project with the previous session's code to make a kind of historical record if you want to follow along, or pick an arbitrary spot and start from there, follow along, or just kind of see the code as it develops. we'll have all these little snapshots. And that's the plan. The plan for what, you ask, because I just dove right in. Well, I'm so glad you asked. Hello, I am Will. This is the second of a series of test streams that I'm doing to get all of the technical stuff, figure out how Twitch works, figure out how my microphone works, if my microphone works, set up green screen lighting, all that just kind of random garbage. Figure all that stuff out now. Do a couple test streams, and then we're going to start working on kind of a big project. One day at a time. We're gonna work on building a game, a video game in Scratch. So we're doing that now. So you might ask, okay, what's the difference? The difference is that after these test streams, we're gonna make something relatively simple, between 1 and 3 hours of coding for these test streams, and then we're gonna call it a day. We're gonna be like, great, we did it. That was awesome. We're done. But ideally, once we have all the technical stuff out of the way, we're gonna make a game that's gonna be, a bit bigger and grander and more ambitious. That has lots of little pieces, and where we just over time just keep slowly adding new features, integrating them, and making it all work. Why do I want to do that? Well, the answer to that doesn't matter that much, but the short answer is that I think one of the most important things about learning to program is realizing that you make a big thing out of small things, and you do it a little bit at a time. And a lot of introductory programming resources give you really great kind of bite-sized snippets where it's like, I want to do this. I want to make the screen scroll, or I want to animate a jump, or whatever. And so it'll give you a single thing and tell you how to do that. But it will tell you that in this decontextualized way where you don't have any other code around. And sometimes that's really helpful, but a lot of times it's really hard to know how to fit code together. A lot of times knowing how to write code that does something is the easy part, and knowing how to integrate that code with all the rest of the stuff that you have, that can be the hard part. So that's my theory. Anyway, I don't want to add my work to like the long list of really awesome resources that are, here's how you do X, here's how you do Y. But I don't see a lot of this kind of more sustained, let's make something big together kind of work in Scratch anyway. So that's what I'm doing. That's my plan. That's my hope. We'll see how it goes. Nobody knows for sure. So, all that said, again, I say hello. What did we do yesterday? We were working on this platformer. You may have been watching, you may not have been. I'm going to run through it real fast just to show you everything that's here. I'm going to right-click, clean up blocks. I'm going to throw away any like kind of little bits of code that aren't doing anything. Looked like it was just that one blank if then. And I'm going to hit the flag, and I'm just going to start doing this, playing this game. So how does this game work? Well, I've got this little player hitbox here. I'm currently pressing the left arrow and the right arrow. Probably one thing I should do in between now and the next stream is set up something where it shows you what my key presses are, because that way I don't have to keep being like, all right, I'm pressing the left arrow key and you can tell I'm moving left, etc. So I'm using the arrow keys, and I am running this little block around this tiny little obstacle course, running and jumping and falling. And we did a bunch of good stuff yesterday. We made it so that we can run to the left, run to the right, jump and fall, and most importantly, we made it so that we can't pass through the walls. So that's a really good start for this kind of game. And if you looked at this is not a terrible place to begin your platformer. But there's a couple of things I want to fix and change about this. So let's see. Let's just think for a minute what we want to accomplish before we start diving into the code. Just for one moment, there's 1, 2, 3-ish things I feel like I want to get done. We'll see if we get them done. I'm not all that good at knowing how long it takes to talk through a programming thing at the moment. But thing number 1, when you press the up arrow key, you jump, and that's pretty good. But you go up and you go down. But there's something about this jump that isn't quite right. This jump lacks a kind of realistic feeling, physicality, and momentum to it. So if you look at how this works, or even if you just watch it very closely, one thing that you will note is that it goes up very smoothly and then goes down very smoothly. You move up and down at the same rate the whole time. So in this case, you are going up 10, well, you're going up 20 units every frame, and you're going down 10 from gravity. So in total, after I hit up, I go up 10 units every frame, and then I go down 10 units once I'm no longer going up. Okay. But if you think about how jumping works in the actual world, you will realize that that is not what it's actually like when we jump. When we jump, we apply a force at the moment of jumping, and that launches us up as fast as it does. Right? We begin moving up at the fastest rate we are ever moving during our jump. Gravity pulls us down and slows us down. Right? So we're going up at a certain speed, but gravity's slowing us down until that speed reaches 0, and then we start falling. So there's a moment when we are not moving at all, instantaneously just hanging in space, and then we begin to fall, and we fall slowly at first, and then faster and faster and faster, right? So we need to accelerate, we need to decelerate on our way up. We need to start out moving very fast, slow down until we hit 0, and then accelerate down on our way down until we hit the ground. So that's thing number 1, is this kind of more physically accurate jumping. And I want to be clear, the important part about this is not that it's physically accurate. The important part is that it makes it kind of feel better when you're playing the game. There's nothing about video game physics that is particularly accurate or accuracy oriented, but mimicking some kinds of real world stuff can be helpful in making a game feel better to play. Because of course we're really used to the natural world and the kinds of movements that happen in the natural world. So when we see things on the screen that are more like those, they seem more realistic, but they also just kind of feel better to us. Why? I don't know. Because we like things we're used to. That's how our brains work. So kind of more physicsy jumping is thing number 1. Thing number 2, and this you might not be able to see all that well, but you probably can. When I jump here, I go up and then down. Boop. But if I jump over here, you can see I go up and then I hang there for a little while. I hang there for as long as I would be in the air. So you can see how that kind of happens. So I hit my head, and instead of bouncing off the top of the ceiling, I just stop, but I keep moving up. So that has to do with how this jump is coded, right? Because what happens is we only move up. If touching ground, change Y by 1, repeat 10, move Y by 20, and we keep going up. We try to go up 10 times and then we start falling. And we try to go up 10 times and then we start falling whether or not we're hitting the ceiling. So we want to bounce off the ceiling instead of just hitting it and sitting there. So that's thing 2. Thing 2 and thing 1 are very related to each other, right? Probably any rewrite of our jumping to involve better physics will also fix this bug here where we float in the sky, but they're slightly separate considerations, so I do want to list them separately. And then the third thing I want to do to change this game is not going to be a fix like these other two. I want to add something new. I want to make it so that when you reach the end of the screen, we go to another level. So that you could have a kind of series of little one-screen obstacle courses that you have to get through. So that's the goal and the plan. So that's what we're going to try to get to. I have just noticed that if I have my screen in full screen mode here, then I cannot see my clock. So I can't know how long I've taken. So I'm going to take one moment. Boop, 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 and I'm going to grab my phone, which has a clock on it. So now, unbeknownst to you, secretly hidden in the distance, I have my phone, and it will tell me what time it is. So that's pretty good. I have everything I need happening all in front of me, so we're ready to dive in and start coding. I'm going to right-click, I'm going to choose Clean Up Blocks, and I'm going to just take a survey of our code here. I'm going to shrinkinate this little screen window so we can see more code at once, and I'm going to kind of see how, if I can get all this code together. Just so it's all a little bit closer together so we can kind of look at it a little more easily. Okay, so what did we write yesterday? We wrote some code that listens for key presses and moves us left and right. It listens for key presses and moves us left and right. And we wrote some code here that when we press the up arrow, we jump. And then we defined our own custom move blocks. This is the really big thing we did yesterday. We defined our own custom move blocks so that we would have a way to tell our character to move that wouldn't allow it to pass through the wall. So that was the big thing. So we wrote these move blocks. Hopefully we wrote them in a way where we don't have to do too much with them again and we can ignore them. I say that and I know, deep in my heart, I know that's not true. I know almost the next thing we're going to do is to make some changes to this. But in some ideal world, once you write these kind of snippets of code, ideally you can write them in a way where you don't have to refer to them again. You don't have to change them and you can just use them. And that's one of the ways that you can write more and more complicated programs, is by writing things that you know work, calling them their own little blocks, and then never having to think about that again. Because one of the big barriers to making a complicated computer program is how much you can keep track of in your own little brain. Not to say that your brain in particular is little, just that, it's hard to think. It's hard to think. And if we can avoid having to think about anything, we should, because there's so many things to think about. We don't, we're always going to be hitting that limit. So anything that we can push to the side and say, okay, we did that. We don't have to think about it anymore. The computer's got it covered. Awesome. That's our whole goal with programming, is to do things so we don't have to think about them ever again. That's an ambitious blue sky goal that we are very, very seldom ever going to realize. But it's noble to try. Okay, so that's the overview. Looking at this code here, I'm looking at this when green flag clicked script. I'm going to zoom in. Pew, pew, pew. Okay. And I'm pretty sure this thing here that says if left arrow key pressed, if not touching ground, move X. Pretty sure this if not touching ground here is redundant, because this was something we wrote early on when we were experimenting, because we wanted to make sure you couldn't walk into walls. So we put this if not touching ground here to make it so that we couldn't pass through the ground. The ground and the walls are the same sprite, so there. It's always going to be a little confusing. So we can get rid of this, I think. I'm just going to throw these ifs away. I'm going to hit go, and I'm going to make sure it's actually still working. Because, of course, it's really easy to think something is going to work and then have it not work. So anytime you make a change to your program, anytime you make any significant change at all, and if you don't know if the change is significant, it probably is. Anytime you make a change, you should always test. Because, of course, if you spend an hour coding and then test it and it doesn't work, you don't know where in that hour you broke everything. But if you do one thing, test it, see what happens. Whatever happens after you went during that test, is, well, you can expect that it's probably related to the thing that you just changed. Of course, that assumes that you actually know everything about the state of your program, which is definitely never true. But, again, we're always trying to get close to these kind of ideal realities. Okay, so we just simplified our code a little bit. That's awesome. If the very first thing you do every time you sit down to work on your project is remove some code from it, you will be a better programmer. So I feel good about this already. So I can move left and right. And what did I want to do? I wanted to make this jump have some momentum to it. So I'm going to hit stop. And we are going to... We're gonna dive in. We're gonna dive into something that's a little bit complex. So I'm jumping. I'm going up 10 pixels every frame. 10. I'm going to alternate between using the word pixels and units to describe our movement, and I'm probably also going to alternate between using the word frame and tick to describe the passage of time in our Scratch project. So y'all can just deal with that. It'll be fine. You go up 10 pixels every frame. We don't want that to happen. We want to go up, we want to start jumping. And so we go 20 pixels on the first frame and 19 on the second and 18 on the third and 17 on the fourth, or whatever. We're going to decelerate. The amount that we're going up is going to go down. We're going to decelerate until it reaches 0, and then we'll start falling. How do we do that? Well, down here, we have this block of code that says move y by 20. But if we write 20 in here, it's always going to be 20. So we need some way to change what this number is over the course of our program. And to do that, we need to make a variable. I'm going to click on variables. A variable is just a place where we can store some information and then change it later. It is able to vary, so it's a variable. Awesome. So make a variable. I'm going to make this variable. I'm going to say for this sprite only. For this sprite only, what does that mean? It means that I can that only this sprite, only the player sprite, can know the value of this variable. Can get information about it. Well, it means that only the player sprite can change it. But it also means that we can reuse the name for other sprites. So these are both important. I'm going to call this. I'm going to call this speed X. I did a little bit of a momentary confusion there because I couldn't decide. Do I want to call it speed X or X speed? The reason I decided to call it speed X is because I want the two speeds to be next to each other alphabetically. So I don't, if I had some other variables that were X and Y, I wouldn't want all the X's together. I want all the speeds together. So speed X, but actually I don't need to make a speed X because we're talking about falling. I'm going to make a speed Y. I'm going to click for this sprite only. I'm going to hit OK. And now I have a variable. This gives me access to a couple new blocks. Gives me this speed Y block. And it gives me this speed Y option on the drop down for all the variables. I'm going to delete this kind of placeholder my variable that Scratch gives us automatically, and I am going to do something different. Okay, so we are going to have to tear a bunch of this code out to make it do the right thing. So where is this code going to be? It's here. Instead of saying if not touching ground, move y by -10, I'm going to say we're going to just always move y by speed y. Then we need to do something about speed y. So what could we do? We could say if not touching ground, set speed y to -10. And then we could otherwise, if we are touching the ground, so I'm going to swap this if here with an if else. I'm going to say if not touching ground, if not touching ground, then set speed y to -10, else, so otherwise, if we are touching the ground, we will set speed y to 0. So I'm going to hit go, and this is great because we have changed our code in some way. We've changed it in a way, we've added this variable, and we haven't broken everything. Now, we haven't fixed anything either. We haven't made it any better, but we've added this variable and we have kept the old functionality. So we're going to keep working on this. And this is a pattern, a development pattern that you'll see a lot that we're going to go through. We're going to make a change that doesn't do anything, and then we're going to build off of that change to actually do something. So move y by speed y. Okay, cool. We did it. Then let's see, when up arrow key pressed, instead of changing y by 1, instead of repeating move y by 10, let's do this. Let's set our speed y to let's see, I want to undo that. Can I undo that? Okay. Instead of, let's set it to 10. Set speed y to 10. And then, I don't know, what does this do? Does this do anything? Yeah, this does about the same thing, right? So instead of changing it, we're setting our speed y. So this says, when we press the up arrow key, we are going to check if we're touching the ground. Okay, we are touching the ground. So for 10 frames, so 10 times in a row, we're going to set our speed y to 10. That means for the next 10 frames, our speed y will be positive 10. So for the next 10 frames, for each frame, we will go up by 10. 10 frames in a row. After that, we will stop setting it, and then it will end up here being back at -10. And we'll start going down again. Cool. But this isn't really what we want, because what we really want is we don't want to, for 10 frames in a row, set our speed to 10, right? Because that gives us this floating, hovering kind of jump. We actually want to set our speed to one big number initially. Well, we'll call it 20. And then, so now if we press, I think if I press up, I'll just fly into the sky. Oh, nope. All right, so now I'm setting it to 20. And then I'm immediately setting it to -10. So that's not right. We don't want, if we're not touching the ground, we don't want to set it to this negative number. We want to slow down. Or we want to slow our ascent, or we want to speed up our descent. So we want our speed y to just change a little bit each time. In particular, we want our speed y to go down by 1. We'll try 1. So now, now we have a great jump, and you can see, let's embiggen it. Ooh, let's do this actually. You can see this happening in a couple ways. I press the up arrow key. I start out going real fast. I slow down, and then I fall down. You can also see that when I jump, the speed starts at 20, and then it just starts going down. You can furthermore see that it continues to go down even when I'm touching the ground. So there is a problem here, but this code is basically working. There's a couple of problems with it. So this, we can see why this is a problem. So now this is, my speed y is negative, 200 or whatever. So I'm going to walk off this ledge, and I'm going to immediately go down hundreds of pixels in one frame, because that's how fast I'm going. That's not what we want. We want to go down nice and smooth. So we need this speed to be being set to 0 every frame that we're on the ground. Now, you might ask yourself, you might think to yourself, but we did that. We did that. We said, if not touching ground, set speed y to 0. We did that, Will. Why isn't it working? Well, to explain that problem, we have to go back into our move y code. Because you have to remember that the whole goal of making these move X and move Y things, the whole goal of making them, these separate blocks, was to make it so that we never actually were touching the ground. So that means at this point in our program, at this point, when I check if I'm touching the ground, I am never touching the ground. I am always a single pixel away from the ground. And that's because whenever I move Y, I move until I'm touching the ground, and then I move 1 pixel to get out of it. And that's just how it works. So, okay. How are we going to solve this problem? Well, I don't know, I'm just kind of inventing, making this up as I go along, but I'm going to say, why don't we make 4 variables? We've already made 1 variable, let's make 4 more. We're going to make, let's make 2 more actually, because we're only going to care about Y for the moment. We might never need to care about X in this regard, but we're gonna care about Y right now. So we're gonna make 1 variable that checks whether we hit our head during a movement, and another variable that checks if we hit the bottom. So if we hit the top or the bottom. Saying hit our head is a little bit funny because, well, it's basically just a head here. Oh, hello, Bryce. That was great. I just went over to check on the chat. That's why I looked over and wiggled my fingers a little bit. And then there was Bryce. Hello, Bryce. That's awesome. So it looks like not only is someone, Bryce, watching, also my setup where I can look at the chat is also working. So I'm pretty psyched about that. All right, so we're just sitting up here. We're sitting up here and our speed is getting increasingly negative. And then I fall down to the ground. So let's fix that. Let's go to this spot. Find the spot in our code where we can check whether we hit our bottom on the ground and make some variables to adjust. Set some variables that keep track of that state. Okay, so I'm going to go over here. I'm going to click make a variable. It's going to be for this sprite only. Again, in general, most variables will be for this sprite only. Because it's usually, you usually don't want variables to be for the whole project. It just makes everything a little bit confusing and complicated. So for this sprite only, I'm going to make a variable called bottom on ground ? I'm going to hit OK. Maybe I'm going to rename it. I'm going to say bottom touching ground. And I'm going to resist the temptation to keep renaming it additionally precise names. And I'm just going to go with this. But the reason I made it bottom touching ground is because I want to say top touching ground. And I wanted the 2 variable names to be approximately the same. So for this sprite only, top touching ground and bottom touching ground, we need to set them. Because at the moment, of course, we've made these variables. We're not doing anything with them. So our program is unchanged. This number just still gets increasingly negative. So hit stop. And we're going to go into our move Y block here. Let's do that. I guess that doesn't help. I want that to somehow make more of this visible, but it's very vertical, so it doesn't. Bryce says if I name them touching ground bottom and touching ground top, they'll show up next to each other in the drop-down menu. That is a good reason. So I said I would resist the temptation to keep renaming the variable, but touching ground top and touching ground bottom. And I put a question mark after them just to denote to myself and anyone who's reading this code that they are questions, by which I mean they will have they will store an answer, and the answer will be true or false. So move Y by distance. What I'm going to do here, every time we move, we're going to reset these to be false. We're going to say, before we try to move, we're going to assume we're not touching. And then if we are, if during the course of the move we end up touching something, we'll set it to be true. So move y by distance. We're going to set these things to false, and then wait till we hit the ground. If we do hit the ground, we will set them to true. And so if distance is greater than 0, so this is if we are moving up, if we're moving up in the y dimension. So if distance is greater than 0, repeat distance. If not touching ground, change y by 1. Else change y by negative, repeat absolute values. This is if we're, so if distance is greater than 0, go up. Else, go down, right? And we had to do this thing with the absolute value of the distance, so that's all fine. And then after we complete our movement, we check if we're touching the ground. So if touching ground, this is after we finished all of our movement. If we are touching the ground, if our movement took us to be intersecting with the ground, this is where we're going to set our little status ground touching flags. So if distance was greater than 0, that meant we were going up. So if we touched the ground, if we ended up touching the ground in a motion that was in the upward direction, that means we hit our head. So we're going to set touching ground top to true. Similarly, else, so if distance is greater than 0, we're going up. Else, otherwise, distance is 0 or less. If it's 0, we're not moving at all, so nothing matters. If it is less than 0, we are going down. So we are going to be thinking about our touching ground bottom variable. Touching ground bottom, we're going to set it to true. So I'm going to make this big. I have a feeling that maybe, yeah, great. So touching ground bottom is true here. All right, so I just trailed off. I was going to say I have a feeling that maybe these will never say true because of the way the code is written, but I think that was obviously a wrong feeling. So touching ground top is false. I jump. Now it's hitting the top. It says true. Touching ground bottom is true. I walk off the edge, or I jump, and it becomes false. So these are working. That's awesome. These little doodads up here, incidentally, are called inspectors, variable inspectors, and they don't have to be there. So after we're done writing this code, we're going to hide them so that they're not kind of cluttering our program, because we're going to have lots and lots of variables in our programs. And if we end up with like 100 variables and they're all inspectors everywhere all over the place, then we won't be able to see anything, and that's bad. So we'll hide them, but it's really useful for now to be able to see the state of your program. It's very useful to be able to see the state of your program, because that's one of the hardest things when you're trying to fix a bug. A lot of what you're doing is you're trying to make guesses about what's happening in order to know why the thing isn't happening that's supposed to be happening. I've been corrected. They're called monitors, not inspectors. But that's okay. I'll probably keep calling them inspectors. To tell you the truth, I'll do my best, though. I can try to change. So we've set these little flags here to true or false. So now we got to do something with them. When do we want to do something with them? It's up here, right? Because up here we said if not touching ground, but this isn't right. This is never the way we've written our code. This touching block, basically is never a helpful block to be using. The only place that block is useful for us is inside these move functions. Outside of these move functions, we have to use our own variables. So instead of saying if not touching ground, we are going to go into operators here. We're going to grab an equals sign. We're going to go to variables. We're going to grab touching ground bottom. And we're going to say if touching ground bottom equals false, we're going to change our speed by -1, because we will not be touching the ground. Because if we are not touching the ground, then we will be going down. So we're going to change our speed by -1. Otherwise, so if it's not false, it should be true. So otherwise, set it to 0. So let's see what happens. Does this do the right thing? It might do the right thing. Look at that. It's stuck at -1. And there we go. That's exactly what we want to have happen. So now we have this nice little jump here. And that's awesome. So we fixed one problem. We fixed the like too smooth gliding up and down jump. We haven't fixed the other problem, which is the getting, when you jump and hit the ceiling, you just kind of float up there. Because we still, our speed is still staying positive for a while. So we just need to do basically the same thing that we did to solve the falling really fast problem, which is when our feet hit the ground, we set our speed y to 0. Similarly, when our head hits the ground on the way up, we should also set our speed y to 0. So let's do it. Let's find where that is. Oh, I guess there isn't anywhere in this. There's not anywhere in this code where we actually do something with that. That's the problem. So, if touching ground bottom equals false, then change speed y by -1, else set speed y to 0. We just want something similar to say if touching ground top equals true. Right, because we want to say if we hit our head, let's set our speed. Get that in there. I'm having trouble. I'm having the hardest time getting this if statement there. Okay, good. So if touching ground top equals false, set our speed y to 0. And that didn't quite work because I said if we aren't hitting our head, set our speed y to 0. That is not right. If we are hitting our head, we want to set our speed y to 0. And then let's see what happens. Now, when I jump, if I hit my head, bonk, I just immediately fall down. That's fantastic. We have fixed the problem. This seems to be working. Everything seems fine. I don't know if it is. You might recall that, we began this project by noticing some things that were wrong that we hadn't identified last time. So, I say it seems fine. We haven't tested that hard. I'm going to throw that not touching ground away. But it does seem fine, so that's good. So for now, I'm going to hide these monitors. I think I go to variables. Yeah, and there's these little check boxes here. Check, check, check. No longer have to see those things because we're pretty happy with our program. But I do think that maybe we're jumping a little too high. This is like a moon kind of physics. It's very, very floaty. So let's change our jump speed. Where we're setting that. This is here when up arrow key pressed. Set speed y to 20. Let's set it to 15 and see what that's like. Okay. I'm still jumping a little higher than I want, so maybe I'm also going to change our gravity speed here. I'm going to change our gravity speed to -1.2 instead of 1.1. I kind of like this little feeling here. I like being able to. I like how this feels and looks. It's a good height. It's a good speed, but I've only played with it for just like a moment here. So I might, in the course of development, in the course of working on this project for longer, I might decide that I want this to be different. I want to be able to jump higher. I want to change it. And I don't want to have to go digging in my code to... I don't have to go digging in my code to find where it all, where these values that I have to change are. So I'm going to make them into variables, and then we can change them more easily. And this is another really helpful, important thing that you can do anytime you're writing a program. Anytime you have a number, a special number that's in your program that means something, if that number means anything in particular, we can make a variable that that kind of labels what that number is. So I'm going to call this variable, again, I'm going to make it for this sprite only. I'm going to call it jump speed. And I'm going to make another variable, and I'm going to make this one for this sprite only too, and I'm going to call it gravity strength. And it's funny to make that for this sprite only, because we could make gravity different for all the different things in our game. And that's different from the real world, but it's sometimes differences from the real world are handy. So set speed y to 15. Instead of setting speed y to 15 when we jump, I'm going to set it to jump speed, and I'm going to set jump speed to 15. 15. Similarly, instead of changing speed y by minus 1.2, I'm going to change speed y by gravity strength, and I'm going to set gravity strength to minus 1.2. This should do nothing, should make no changes to our game at all. Everything plays the same, which is great, but we can now fiddle with things a little easier and be like, well, what if I make this a really big number, 50, and then also make this like a bigger number, like -5? What happens then? Then I jump really high and fall really fast. It's kind of fun. I was pretty happy with -1.2 and 15, so I'm going to just stay with them. But you can see how you would fiddle around with that. Yeah, I don't know. Maybe it's still a little... Let's fall a little faster. Let's just fall a little faster. Let's try 1.3. Am I just fiddling around? Is like by 0.1 at a time? Maybe that's just not enough. Let's do something serious. Let's do -2. Oh, I wrote -2, which is not a number. I mean, -2 is a number. It's +2, but the double minus sign is not a number. Okay, so great. This is fine, whatever. I'm going to stop fiddling with it. I am going to note that I have now made this jump unjumpable. So I'm going to go into my ground, and I'm going to pick it up, and I'm going to move this little platform down. And that is one of the reasons why I decided to use vector mode instead of bitmap mode. So I could make decisions like that. So now I can make this jump here, make this jump here. Oh, can I? I think I can. I think I can do it. Although, yeah, there you go. And I can get over there. So that's pretty fun. It is 4:58. I started a little bit late. So I am going to add this one last little feature. I'm going to add this one last little feature here to make it so that if I hit the end of the screen, I can go to another level. And then we're gonna call it a day. Oh yeah, I could somehow I can turn these things into sliders. I thought I could do it by double clicking on them. Oh, I probably have to do it here. Yeah, there you go. Right, I can double click on these, and then I could kind of adjust them on the fly a little bit without having to go in here and type things and press the green flag over and over again. And I can go, if I right click on these, I can change the range. So what's a good range for jump speed? I don't know. Let's call it 1 to 50. And then what's a good range for gravity? Well, gravity has to be negative. I mean, for our game to make much sense, gravity has to be negative. So our maximum value is going to be 0. And our minimum value is going to be -10. And there we go. I could adjust these things. Oop. Yeah. Okay. Can I change the... Is there a way that I can make this go by not a single... Oh, I think it goes by 1, but maybe if I write a 0.0 here, it will go by fractions. Yeah, that's right. Cool. Let's just make these point zeros. Nice. Right, so what I just did there is I changed this from saying 1 to saying 1.00, which of course is the same number, but Scratch looks for whether there is a decimal point here. And if there is a decimal point, then it lets us change by smoother increments. So there you go. Now I've made this crazy. I'm going to hit the flag again. Okay, great. But I'm going to hide these. Having done all that, I actually am pretty happy with these values. I'm going to hide all that stuff. I am noting that it is that making these like last pixel jumps is a little bit more difficult than I expect it to. And the reason it's more difficult is because most video games that you've ever played probably have a little bit have some features that make it easier for you, where they give you a kind of grace period if you have walked off the edge to make the jump. And I have not written that grace period in, and so my game feels harder than it actually is. All right, no, it doesn't feel harder than it actually is. It feels hard in a way that you don't expect it to. Okay, we want to get to the next level if we get to the right-hand side of the screen. We're going to start at the left. We're going to go to the right. If we get to the right-hand side of the screen, we'll appear on the left-hand side of the screen, and then we'll get a new costume for the ground. We're going to have a whole new set of platforms. How do we do that? We need to add some code, and we need to add another costume. I'm going to add the next costume first because it's just going to be it's going to be pretty easy. I'm going to right-click here. I'm going to choose duplicate. The reason I'm going to do this is because I want this ground to be at about the same point. And so there you go. I don't know. I'm just going to move some stuff around. It doesn't actually matter. None of this matters. What if I just do this? Great. So this is costume 1. This is costume 2. Why don't we reverse them? Because then costume 1 is the really easy level where all you have to do is learn to jump. And then costume 2, we can do something. Here, we can do this, so that you have to make this kind of trickier jump here to get to the next level. Great, look at that. Now these are called costume 2 and costume 1. Costume 2 and costume 1 are bad names. One of the things that we're doing, always fighting against in programming, is we're fighting against bad names. Left to their own devices, everything will be named badly and wrong, and you will be confused. So, costume 2, we're going to call this level 1. And this one we're going to call level 2. Easy. Jumping over to the code, we're going to go to our player, and we are going to, in this big long forever loop here, we're going to add one more if statement. We're going to check whether we are touching the right-hand side of the screen. So, how am I going to do that? I'm going to say if. I'm going to go to operators. I'm going to grab a greater than. I'm going to go into motion, and I'm going to grab this block here that says X position. Because, remember, this X here, this X is a number that represents how far to the right we have moved. So if I go to the left, it gets more negative. If I go to the right, it gets closer to 0 and then more positive. And it will go to, get to about 244 is the highest this is going to go with this sprite at the moment. So this number just keeps going up until we hit the edge. So if my X position is greater than, I'll say 235, then we want to go back. We want to go back. We want to have the costume change, and we want the player to appear on the other side of the screen. So I'll do the first part first, the second part first. I'm going to do the thing with the player first because I'm already here in the player's code. I'm going to say if X position is greater than 235, then I'm going to set my X position to negative 235. So now, if I, Oh, all right, let me switch to the level 1 costume. Now, if I do this, I just loop around and I can endlessly go to the right, but I don't actually end up getting anywhere. So here we are, player hitbox. I want this ground to switch costumes, right? I would like it to go do. I'm going to the right. I get to there. This wraparound happens, and this costume change happens. That's what I want. But if I go into player, and if I scoured through all of these blocks here, if I did a whole scouring of the blocks, I would find that there is no way that this player, that I can write code in the player that tells the ground to change its costume. The player is not allowed to change the ground's costume. Only the ground is allowed to change the ground's costume. So what the player needs to do is sound the alarm and tell everyone that it got to the next level. And then the ground can listen for that and change its costume if it hears that a level change has happened. It'll say, all right, well, if it's a level change, then I guess I go to the next costume. The way we do that, the way we have sprites talk to each other, communicate with each other, is with a thing called a broadcast, which is in the events category. So there's a thing here that says broadcast message 1. I'm going to stick it here. I'm going to stick it before we do the switch, or before we wrap around. I don't really know if it matters. I'm going to click broadcast message 1. I don't want to be called message 1 because, again, we're always fighting against bad names. I'm going to call it next level. We're going to broadcast next level. Ground is going to have its own script. We're going to have a hat block here that says when I receive next level. And what am I going to do? I'm just going to go to the next costume. So now, now I can go there, and then I can loop between these two costumes forever. There's a couple of final little kind of housekeeping things I want to do with this before we call it. We're basically done. But at the moment, if I get over here and I press stop, and then I press the green flag, I start in the middle of the screen on the second level, which is not what I want. I want the player to always start probably over here, probably there. And I want the costume, they'll always start on level 1. So when the green flag is clicked, there's two things I want to have happen. I want to set my X position to whatever this X position happens to be. It happens to be -219. Very conveniently, whatever X position the player is currently in is automatically filled into these blocks over here. So that's just a really easy way to get the numerical representation of where you are. So when the flag is clicked, I'll set X to -219. I don't want to set Y to 150. Maybe I'll set Y to -95. This says -106. I want to be just a little bit higher, just so that you fall a little bit. Maybe -70. I just like the idea of throwing you in this situation where you can see that you fall until you hit the ground. Maybe that's silly. I don't know. At the very least, having it like that lets us know if we ever break gravity for some reason while we're working. So the ground, I want the ground to start at a specific costume. So that's in looks here. I'm going to need a block that says switch costume. And then events when green flag clicked, right? That's the start button. So when the start happens, we're going to switch costume to level 1. Click the green flag. We start here. We go over to the right. We get to the next level. I don't like this. I wanted these things to be lined up. I messed that up somehow. So I'm going to go on in here and just inch this over a little bit. Okay. Now I'm going to try again. Oh, I probably didn't need to stop that. I did, though. Gives me an excuse to play my game. And it wraps around, right? So if you wanted to, you could make new levels for this game just by adding additional costumes. you could just make a new costume. And if you make a new costume, it will just automatically be in the game here. So, I'm just going to make a new costume, but this costume is going to be crazy. It's going to have green blocks instead of black blocks. And now we start and we go here. And then, oh my God, we're in green block world. That's amazing. So it's really easy to add a new level. So that's pretty fun. So that's everything I want to do with this project today. I may do one more stream with this platformer code just before jumping into the other project. Because there's a couple more things that I think might be fun to do. I think I probably will. I'll do that next week. Once I've got all of the technical difficulties all sorted out, then I'll probably try to have a regular schedule where I'm doing this, working on the project at the same time every day or every other day or something. I'm still thinking all that through. So I'm not sure all that logistics stuff. So it's going to be irregular for the next couple times as we get all of the logistics sorted out and the technical stuff and just get everything working. But this is awesome. This was really fun. Thanks everyone for watching. Thanks Bryce for jumping in chat and helping out with some of the questions. And I'm going to call it a day. But before I do that, I'm going to hit save now. Always remember to save. I'm going to go to my project page, which is here, see project page. I'm going to click share. And that's it. All right. Thanks, everyone. And I will see you next time. Oop.